Hello and welcome to Algebra 1 Lesson 8. In this video, we're going to talk about applications of linear equations. This is going to be the first section of that. And a lot of you will know this as solving word problems. So before we kind of get started, I just want to tell you that once you've mastered the material that we've presented in the first 7 sections of this course, you're ready to move on and start solving word problems. Now, this is where a lot of students really get frustrated. When you start solving word problems, it's unlike solving the problems you've gotten before. Now, in addition to solving an equation, you also have to figure out how to get the equation. So that's what makes word problems so difficult. You have to read through and figure out your own equation before you even solve it. So the first thing I want to do here is I want to go through a brief procedure that we can use when we're solving a word problem. Now, your textbook might have something that's different. If you want to follow that, do so. If you want to follow mine, do so. If you want to follow your teachers, do so. The main goal here is to get a procedure that you can follow each and every time until you feel completely comfortable with word problems. All right, so solving a word problem. So the first thing and probably the most important thing is to read the problem carefully and determine what you are asked to find. I can't tell you how many students I've tutored and, we do a sample problem and they don't even know what they're looking for. So this is probably the most important thing. Just to read the problem carefully, again, and determine what you are asked to find. I always make my tutoring students write out, hey, this is what I'm looking for, so that they know what the overall goal is. All right, now the next thing is to assign a variable to represent the unknown. Sometimes there's going to be more than one unknown. And as we get through algebra, you're going to have a lot more complicated scenarios than you're going to face when you're just working with linear equations in one variable. For the problems we're going to look at here, if we have two unknowns, we're going to be able to represent one of the unknowns in terms of the other. All right, so the next thing we're going to do is we're going to write out an equation. And the way we do that, we read back through our problem, and we're going to see that something is equal to something else. They're always going to give you a way to set up an equation so that you can get an answer. Now we get to the easy part. We just solve the equation. So this is the part that we already know how to do. Then part 5, we state the answer in terms of the problem. So in regards to a word problem, that's generally going to be a nice little sentence describing your answer. Then lastly, we want to check the result and make sure it's reasonable. So for example, if you're asked how many people are on a train and you get an answer of 24.65, you're probably wrong, right? Because there's not 0.65 of a person. So you're looking for a nice whole number. Or let's say they ask how many people are on a train and you get -7. Well, that doesn't make any sense. So when you're solving word problems, you need to make sure that your answer is reasonable. If it's not, you probably made a mistake. All right, so let's start out by looking at some different types of problems that you will encounter. The first type is called sums of quantities. So you're going to see these right away when you get to your Algebra 1 section on applications of linear equations. And these problems involve finding two individual amounts, sometimes it's more than two, when the sum is known. So that's the key. So you're finding individual amounts when the sum is known. So let's take a look at an example. So the Phantoms won 8 more games than the Aztecs last year. Their combined wins were 32. Find the number of games won by each team last year. So kind of our first step is to read the problem and determine what you're asked to find. So we've read the problem. I recommend reading it more than once and writing down specifically what your goal is. That way you're going to have a laser focus. So again, the Phantoms won 8 more games than the Aztecs last year. Their combined wins were 32. Find the number of games won by each team last year. So this is my goal. I want to find the number of games won by each team last year. So at the end of the day, I'm going to be writing a nice little sentence saying that the Aztecs won this many games and the Phantoms won this many games based on the information given in the problem. All right, so now we're going to move on to the next step. And this step is a little bit challenging for students. So I want you to pay close attention. So this step is assign a variable. So how do we assign a variable? What do we do? Well, remember, we're assigning a variable to represent the unknown. In this case, we have two unknowns. And our two unknowns would be how many games, so how many games did the Aztecs win? And then also, how many games did the Phantoms win? These are our two unknowns. So when we get to the stage of assigning a variable, it really doesn't matter which one I assign a variable to. So in other words, we could say let x equal the number of games the Aztecs won. Now you might be saying, okay, well, if x equals the number of games that the Aztecs won, what are you going to do about the Phantoms? Well, you're going to express the number of games that the Phantoms won in terms of this variable x. So let me show you how to do that. Let's scroll up to the top. So if I let x equal the number of games that the Aztecs won, well, the Phantoms won 8 more games than the Aztecs last year. Again, let me kind of repeat this. X is the number of games the Aztecs won. The Phantoms won 8 more than that. So I can just say that then x plus 8 is going to be equal to the number of games the Phantoms won. Very, very simple. And I know at first it's a little confusing, but again, if you read back through the problem, it makes perfect sense. So let's go back up there. So the Phantoms won 8 more games than the Aztecs last year. Okay, 8 more. Their combined wins were 32. Find the number of games won by each team last year. So again, if I'm letting x be the number of games that the Aztecs won last year, well then x, that number again, plus 8 will be the number of games that the Phantoms won. So now we have represented both of our unknowns in terms of this one variable x. Okay, so again, we let x equal the number of games the Aztecs won, and so then x plus 8 is the number of games the Phantoms won. Now the next step is to write out an equation. And in order to do that, you have to make use of the information given to you in the problem. So again, we're going to read it one more time. So the Phantoms won 8 more games than the Aztecs last year. Their combined wins, and this is key right here, their combined wins were 32. So if their combined wins were 32, that means that if I take the number of games that the Aztecs won, which is x, and I add to that the number of games that the Phantoms won, which is x plus 8, that amount should be 32. So that's how you go through and set up your equation. Again, this is the number of games that the Aztecs won. Okay, number of games the Aztecs won. And then this is the number of games the Phantoms won. Number of games the Phantoms won. If I sum those two amounts together, their combined wins, I get 32. Right? This is the combined. So I can go through and solve the equation, find the value of x. I'll know the number of games the Aztecs won. I can add 8 to that value and find the number of games the Phantoms won. Let's go ahead and crank this out. So if we have x plus this quantity x plus 8, so we'd have x plus x, that's 2x, plus 8 equals 32. Subtract 8 away from each side of the equation. This will cancel, and we'll have 2x equals 32 minus 8 is 24. Divide both sides of the equation by 2, and I'll have x is equal to 12. So again, what does that mean? X equals 12 is not the solution. Don't circle that on your paper and go, I'm done. You're not, because with a word problem, you have additional work. You have to go through and make sense of your answer. So that's why after we finish step number 4, solving the equation, for step 5, you're going to state the answer. And in order to be able to state the answer, you've got to be able to go back up and make sense of it. So X is the number of games the Aztecs won. So that means the Aztecs won 12 games. So the Aztecs won 12 games, while the Phantoms won, remember, they won 8 more games. So 12 plus 8 is 20, right? Remember, you had X plus 8 to represent the number of games that the Phantoms won. 12 is X. So we now know the value for X, which is 12. Plug that in. 12 plus 8 would be 20. So while the Phantoms won 20 games. So the Aztecs won 12 games while the Phantoms won 20 games. So now you've answered your word problem. And you just want to read back through the problem and make sure that your answer makes sense. So the Phantoms won 8 more games than the Aztecs last year. Well, yeah, the Phantoms won 20 games. The Aztecs won 12. 12 plus 8 is 20, so that checks out. Their combined wins were 32. 12 plus 20 is 32, so that checks out also. So it looks like we have the correct answer. Again, the Phantoms won 20 games and the Aztecs won 12. So one question you might have is, what if I started out by saying, okay, well, the number of games that the Phantoms won would be represented with X. So let's try it that way. Let X equal the number of games the Phantoms won. So then X minus 8 is now the number of games the Aztecs won. So you can do it either way. It doesn't really matter. You're going to get the same answer. So we let X equal the number of games the Phantoms won. And so then X minus 8 is the number of games the Aztecs won. And again, their combined wins were 32. So I can do the same thing as far as setting up an equation. So X plus this quantity X minus 8 equals 32. X plus X is 2X. Minus 8 equals 32. Add 8 to both sides of the equation. That's gone. I'll have 2X is equal to 40. Divide both sides of the equation by 2. And what I'm going to have now is that X equals 20. And you might say, well, you got a different answer. Before you said X equals 12. Remember, we changed what X was representing. So, of course, the answer is going to change. But we still got the correct answer and the same answer as before. X equals 20 here because, again, we let X equal the number of games the Phantoms won. Okay? So the Phantoms won 20 games. And then X minus 8 is the number of games the Aztecs won. So 20 minus 8 is 12. So again, you get the same answer. The Phantoms won 20 games, and the Aztecs won 20 minus 8, or 12 games. All right, let's take a look at another one. So there are 3 girls in a family. We have Jessica, Jennifer, and Ashley. Ashley is 3 years older than Jessica. Jennifer is 5 years younger than Jessica. Their combined age is 34. Find the age of each girl. So when you read this problem for the first time, again, your goal is to figure out what you're being asked to find. We're being asked to find the age of each girl. This is another problem where we're trying to find the individual amounts, given that we have the sum of the individual amounts. So their combined age is given to us. It's 34. So if there are 3 girls, Jessica, Jennifer, and Ashley, they represent our 3 unknowns. We want to find the age of each one. So when we move on to our next step, which is to assign a variable to represent the unknown, well, you have 3 unknowns here. You don't know the age of Ashley, you don't know the age of Jessica, and you don't know the age of Jennifer. Now I'm going to set a variable equal to one of their ages, and then I'm going to express the other girls' ages in terms of that one variable. Now here's a little trick. When you read through your problem, if you have one of the individuals that is involved in both comparisons, so in this case you have Ashley is 3 years older than Jessica, and then Jennifer is 5 years younger than Jessica. So Jessica is involved in the comparison with Ashley and also with Jennifer. So I'm going to go ahead and let X equal Jessica's age. Now, I can express the other girls' ages in terms of this variable X. So I can say then, for Ashley, we're told that Ashley is 3 years older than Jessica. So if she's 3 years older than Jessica, and Jessica's age is X, well then X, again, Jessica's age, plus 3 is going to equal Ashley's age. And then what about Jennifer? Well, it's also telling me that Jennifer is 5 years younger than Jessica. So that tells me I can put then X, which again is Jessica's age, minus 5, okay, minus 5 because Jennifer is 5 years younger. That's going to be Jennifer's age. So we have X as Jessica's age. Then we have X plus 3 as Ashley's age, right? Because Ashley is 3 years older than Jessica. And then we have X minus 5 as Jennifer's age, again, because Jennifer is 5 years younger than Jessica. All right, so in the next step, we're asked to set up an equation. So how do we set up an equation here? Well, again, just like we saw in the last problem, we have the sum of the individual amounts that are going to be equal to something. So if we look at the problem again, we're told that their combined age is 34. So what that means is if I take X, which is Jessica's age, and I add it to X plus 3, which is Ashley's age, and then I add it to X minus 5, which is Jennifer's age, I should get a value of 34. So we simplify this. X plus X is 3X. And then plus 3 minus 5 would be negative 2. So I can put plus negative 2, or I can just put minus 2. It doesn't really matter. So this is equal to 34. And then I'll add 2 to both sides of the equation. That's gone, and we'll have 3x equals 36. All right, so now we'll divide both sides of the equation by 3 so that x can be by itself. This will cancel with this, and I'll have x is equal to 12. And you never thought that solving the equation would be the easy part, but now it's become that. So I have x equals 12, but again, I'm not done. Please don't stop and turn your test in with this answer on it. You will be wrong. You have to translate this now into a sentence. So x equals 12. X is Jessica's age. Jessica is 12 years old. Ashley, remember, we represented her age with x plus 3 because she was 3 years older. Jessica is 12 years old, while Ashley is 15 years old. And lastly, Jennifer, she's 5 years younger than Jessica, right? We represented her age with x minus 5. So x is 12, 12 minus 5 is 7. So, and Jennifer is 7 years old. So Jessica is 12 years old, while Ashley is 15 years old, and Jennifer is 7 years old. So go back to your problem and make sure that it makes sense. Make sure that the answer is reasonable. So there are 3 girls in a family, Jessica, Jennifer, and Ashley. Ashley is 3 years older than Jessica. Well, we said Jessica was 12, so Ashley's 15. Jennifer is 5 years younger than Jessica. Well, we said that Jessica was 12, and so Jennifer is 7. Their combined age is 34. So we have Ashley's age, which is 15. We have Jessica's age, which is 12. And we have Jennifer's age, which is 7. So if you were to sum those amounts, 5 plus 2 is 7. 7 plus 7 is 14. Put the 4 down, carry a 1. 1 plus 1 plus 1 is 3. So yeah, that works out. This does sum to 34. So we have the correct answer. Again, Jessica is 12. Jennifer is 7, and Ashley is 15. All right, let's take a look at a very easy problem to kind of conclude our introduction to applications of linear equations. So we're talking about consecutive integer problems, and you might see these in your book. Some books skip it because it's so easy. But basically, when 2 integers differ by 1, they are called consecutive integers. So if I have the numbers 2 and 3, they're different by 1. Or 14 and 15, or 123 and 124. That's what we mean by consecutive integers. So let's take a look at a problem. So 2 pages that face each other in a pamphlet have 33 as the sum of the page numbers. What are the page numbers? So we're trying to find what are the page numbers. So this is an example of a consecutive integer problem. If you think about a book or pamphlet, if you have a page here and here, and they face each other, so let's say this is 1 and this is 2, or it could be let's say 567 and 568, so on and so forth. So we're trying to find the individual page numbers given that the sum is 33. So again, just like we solved the previous two problems, we're going to let x equal one of them, okay, one of the page numbers, and then we'll represent the other page number in terms of that variable x. So let's let the smaller integer be x. So let x equal the smaller integer. So then, since they differ by 1, we could say that x plus 1 is equal to the larger integer. So now it's easy to set up the equation because we know that the smaller page number plus the larger page number, and I put smaller integer, larger integer. You could have put smaller page number, larger page. It really doesn't matter as long as you understand what's going on. Really, we're thinking that, okay, x now, which again is the smaller page number or the smaller integer, plus x plus 1, which is the larger page number or the larger integer, should sum to 33. So let's go ahead and set up that equation. So we would have that x plus 1 is equal to 33. Again, this plus this gives me this. Okay, so that's my equation. So now to solve it, simplify over here, you'd have 2x plus 1 equals 33. Subtract 1 from both sides of the equation. And we're going to have 2x is equal to 32. Divide both sides of the equation by 2. And I'll have x is equal to 16. So again, I'm not done. Very important that you go back up and figure out what that means. So x is the smaller integer. So that means that the smaller page number is 16 and the larger page number is 17. So for the page numbers, we could say that the two page numbers are 16 and 17. Right? If you take 16 and you add 17, you're going to get 33, right? And the two pages do face each other in the book. So if you had a book or a pamphlet or whatever it is, this is 16, this is 17. If you close the book, the two pages would face each other.